Danke.
Yeah, thank you very much. Did you know that we create 400 million terabytes of data each day? That's a huge amount of data, and a large portion of that is created in the industrial environment. I'm Christian Homma, Innovation Manager for Digitalization and AI at Siemens, and I'm here together with my colleagues, Carolin Rubner. She is heading a research group on decentralized architecture, and Harald Gossner from Intel. He is project lead of the Semiconductor X project, a data space project. So we will explore today how we can leverage data. And if you look at the automation pyramid, you have the connectivity layer, of course, on top. On bottom, on top, you have the applications. And in between, there is this huge data layer I was talking about. So industrial intelligence, that's one of our hunting zones where we want to tackle future business opportunities with respect to this data layer. And you might know that customers have, of course, similar problems in the realm of manufacturing. Apart from the given poly crisis, we have the operation efficiency that needs to be optimized. That's about machine utilization, performance, but also product quality, where a closed loop scenario could help to integrate data to produce better. Then we have the production engineering, when you want to bring a new product to your market or you want to integrate a new machine into your setup. For example, you could get help from a co-pilot that creates your PLC codes. You could see here at one of our booths. And also virtual commissioning is a topic here. Lack of workforce, it's very important. We all are lacking the experts. Experts retire. We need to retain the knowledge. We need to pass it on to the new employees. So also in that context, maybe a multi-language tool somehow needs to capture the information and then pass it on to the next generation. Also, a maintenance co-pilot could help you here, which is also in our booth. Cybersecurity, I think everyone will agree that this is of utmost importance. And in 2023, 1/4 of the cyber attacks were actually on manufacturing hardware. So this should all tell us that this is very, very important. Frugal competitiveness, on the other hand, that's to a more with less strategy, right? The next billion middle-class consumers, they will be in India, they will be in China, and they want to get 80% performance, but maybe only at 20% of the costs, right? So with frugal competitiveness, we can address those new customer group. And then we have the large group of sustainability. So with the respect of data, we have different decision support levels. On the lowest level, that's just the descriptive analytics. That might be a dashboard where you are told in the example of the energy, how much energy you consume. The diagnostics level, that's more an efficiency analysis. Which machine consumes how much energy? Then you have the predictive level, that's more forecasting what will happen in the future. So based on your current consumption and maybe the weather forecast, your HVAC needs to be ramped up, which then leads to prescriptive analytics. So what should I do about that? With that knowledge in mind, the computer can tell me how I can still produce a lot and be energy efficient. And of course, what would be great is the autonomous level where the machine does everything itself. But I think, depending on the topic, that still takes a while, right? So to do proper analysis, we need data, Carol, right?
Yes, we do need data, or even more important, we need the data and the information that we get from the data. So often this is said, this is the new gold, right? And we need this in order to do analytics, to create and then use these industrial applications where we can already see first examples here on the shop floor. And in order to unlock this potential and use the data for the manufacturing domain, we really need to look at new ways of collaborating with partners and how we do this across the whole value chain that we have in our ecosystem. And we need to share data in order to create an initial transparency along this. In Manufacturing X, companies come together in various projects to collaborate in this big Manufacturing X initiative. It's a German government-funded initiative where we target German, European, and global manufacturing industries, and we drive digitalization forward. And together, we look at these challenges. How can we jointly use the data for the respective industry and have the three big drivers: resilience, sustainability, and competitiveness? Resilience, this is important. You all know during Corona or when there was a trouble in the Suez Canal, we need to make sure that our supply chain is reliable and that we're able to continuously produce what we're looking to produce. Sustainability is a very, very important topic, not only for Siemens, but really for the whole industry. And so we need to have the transparency, again, across the supply chain in order to make the right decisions. And especially for us here in Germany or Europe, we also need to make sure we stay competitive and are able to use the data that we're producing in our manufacturing domain to make the best decisions that we need to do in order to have the best benefit. So if we take a look at Manufacturing X, it really is a group, it's an initiative, and it was started with Catena X and Factory X as two really big players. Out of Factory X, we're developing shared services and a technological foundation. And the cool thing then, a number of projects now have started and they will be reusing this technical foundation and adapt this to specific use cases in that specific domain. And the domain we're going to look at today is semiconductor.
Right. So we have talked about value chains already and data space. So what are the unique challenges of the semiconductor domain, Harald?
Yeah, there are a couple of peculiar challenges in the semiconductor industry and the supply chain. Basically, there are two aspects to remember. We are a highly specialized industry. We have highly specialized partners in the supply chain. We are producing dies, parts with tens of billions of transistors in the nanometer dimension with very high yield. So to do so, our material suppliers are very, very specialized, high pure material, very narrow specifications. So we are in an industry where there's a very good partnership already for many, many years. Intel, my company, and others worked for a long time to get this interwoven network of partners across the industry with a certain base of data exchange. Yeah. So we are starting from a relevant, good base. The second aspect is we are producing billions of parts in one design, but it might be that we have to trace back one individual part out of this billion. We need to trace back right to the point with all the technical details, with all the production details, because of quality issues or because of counterfeiting problem in the industry. So that's really where we have to pay attention when we think about traceability.
And what does that mean for the data space now?
Yeah, of course. Data is important. You see it. This is all about data. So we have to target this when all these aspects when we are thinking about extending now the approach for data space. What is the type of data to be exchanged? Yeah, and this is actually the key topic of the Semiconductor X project, to use basically the methodology which is developed in this Catena X and Manufacturing X projects, but apply our specific need. Yeah. The most important thing is here to get the right partners. So we started with 16 partners back in May, and since then we were growing and growing with associate partners, and of course Siemens plays a very important role here.
Yeah, semiconductor industry is also very important for Siemens. So we enable smart, secure, and sustainable semiconductor design and manufacturing, right? And this is why we joined Semiconductor X, to really look at how we can collaborate with the partners in the ecosystem and establish these two important topics: traceability, to have the transparency across the supply chain, and sustainability, to really collect this data again along the value chain to make the right decisions.
This is very interesting. You were talking about collecting data along the value chain. That means also sharing data somehow across the value chain. And from our interviews, we learned that people are kind of reluctant. So maybe if we ask the crowd, who would be willing to share their industrial data with the partners? Yeah, okay. So I think there's room for improvement. But that's of course what we also learned from our interviews, and there are certainly some ways around it, right? You could, for example, say, I have an own model trained for just my data on premise on my machine, and nobody sees the data. On the other hand, you could have maybe a foundation model that you fine-tune with your data, or the big step is a kind of federated learning, where everybody puts some data anonymized into the cloud, and then some magic happens and we all get great models that we could use. So in the semiconductor industry, I assume that this is even more difficult regarding security issues. How do you tackle that?
Sure. I mean, that's not only for the semiconductor supply chain. It's a problem which is shared between all the manufacturing supply chains. What you also have seen in this chart of the many projects where everybody is worried about its own data, about production data, about IP. Yeah? So what actually Manufacturing X is pursuing is not to put all the data somewhere in a central hub or dump it in a central pool and then extract data. The idea is really keep the data at the place where it's owned and only exchange where it's needed. So it's a kind of a contract between partners to exchange data for a certain purpose. And the technology which was developed basically at Catena X and now further expanded by these X projects is this what you see here. Basically on the right-hand side, you see the data inside the company. Yeah? So it's kept there. It's prepared in a way that you can ship it out. These are these digital twin containers. In the language of Manufacturing X, it's the asset administration shells. You might have known this or seen this. And on the other side, from my side now, on the right-hand side, you see the federated data space, where there's a policy, there's access rights, etc. So there's control, which partners talk to whom, and which data can be exchanged. And the technical part which connects the two spaces is this Eclipse Data Connector, which has also been developed and proven to be working in this Catena X projects. So this is what we are taking over and implementing now for the Semiconductor X industry, for the semiconductor supply chain. And we have to take care that doing all this, the data are secure and the data are verifiable. This is very important for us to make sure that there is no data stolen, there's no data which is corrupted and we draw wrong conclusions from it.
Right. And if I got it right, there is no central data authority needed.
No, it's really on a contract.
Right.
Yeah? You maintain the right to give out your data on your own. That's your own decision. Yeah? So there's nobody else deciding for you what to do with the data.
So that's really the basis of all of these projects. It's decentralized architecture, so that's why it's a very good way to establish a trusted data ecosystem.
And Catena X was kind of the front runner here. And now we are transferring it to the other industries we have seen on the slides.
Yes.
And the good thing is that we are not just confined in our own domains. With this common technology, when everybody is applying, we can really connect the different data spaces across industrial domains. Yeah?
Right. Cool. So this is about the topic of then how to use this industrial data. And we have, have we mentioned AI yet? I'm not sure because so far everything has been technology agnostic, right? We were talking about data analytics, but what kind of analytics, that kind of doesn't matter. But I just want to have one remark to the AI topic, because the German Council for the German Ethics Council, they recently published a paper on AI where they gave a recommendation in the medical business actually, where they said in cases where careful empirical studies have demonstrated an AI application's superiority over conventional methods of treatment, AI must be made available to all relevant patient populations. And I find that very interesting because we're still discussing, is AI now something good or something bad? Will it be kill the world or will it be the Holy Grail? And you see, even in the medical domain, which is really highly regulated, maybe not as much as semiconductors, but close, that even they claim that AI must be used if it is better. And I found that very interesting.
And AI is actually the power tool now, which helps you to be more efficient, to be more resilient, to be more sustainable. But to apply AI, you have to have data, structured data. So this is where this concept really helps.
There the circle closes. And we also have to close the session again. So I truly believe by embracing this industrial intelligence and especially the data-driven solutions, we can overcome the challenges I've mentioned in the previous slides, facing manufacturing and unlock a future of greater resilience, sustainability, and also competitiveness for all of us.
Yeah, so it's really a way to have these new ways of collaboration, a trusted ecosystem, and then really data-driven innovation, because that's what we're all about.
Right.
So yeah, I have the view, of course, of the semiconductor industry, and I see semiconductor at the heart of this industrial revolution. So when we really push this forward and we establish an end-to-end supply chain concept by collaboration in this data space, we are really able to build the ecosystem, the data ecosystem for the future of manufacturing.
Thank you very much. Thank you very much for having us here. Have a nice day at the fair and maybe look also at the booths.